AI agents actually think before they act. We're witnessing a fundamental shift in artificial intelligence. For years, AI systems have been glorified parrots, impressive at mimicking patterns, sure, but ultimately waiting for humans to tell them what to do next. AI agents are different. They're autonomous software systems that perceive their environment, make decisions, and act on those decisions without someone hovering over their shoulder. Think of traditional AI like a sophisticated calculator. You input a query, it processes the data, spits out an answer, then sits there waiting for your next command. AI agents, by contrast, are more like having an actual assistant who understands the bigger picture. Tell them you need to organize a company off-site, and they'll coordinate schedules, book venues, send invitations, and follow up with attendees, all without you checking in every 5 minutes. The difference isn't just incremental, it's a completely different approach to automation. The technical architecture behind AI agents combines several AI technologies into a unified system. At their core, they operate through a continuous perception, reasoning, action loop. First, they gather information from their environment through sensors, APIs, application programming interfaces, or user inputs. Then they analyze this data using machine learning models and natural language processing, or NLP, the tech that lets computers understand human language. Finally, they execute actions based on their analysis. But here's the crucial part. They don't stop there. AI agents monitor the results of their actions, learn from outcomes, and adjust their approach accordingly. According to Aaron Chason, Vice President of Product and Solutions at Vast Data, a data platform company working extensively with AI infrastructure, the defining characteristic of AI agents is their ability to plan and execute multi-step tasks autonomously. This autonomy fundamentally distinguishes them from chatbots or conventional AI models that require explicit human guidance for each step. An AI agent handling customer support, for instance, doesn't just retrieve canned responses. It understands context, accesses multiple data sources, determines the best course of action, executes that action, and follows up if needed, all without escalating to a human unless truly necessary. The real-world applications are already transforming industries. In healthcare, AI agents are analyzing patient data streams, identifying concerning patterns, and alerting medical staff to potential issues before they become emergencies. These systems can monitor thousands of patients simultaneously, something no human team could accomplish. In financial services, AI agents are detecting fraudulent transactions by recognizing subtle patterns across millions of data points, learning to distinguish legitimate unusual activity from actual fraud. Customer service is perhaps the most visible application. AI agents now handle complex inquiries that previously required experienced human representatives, resolving issues by pulling information from multiple databases, understanding company policies, and making judgment calls within defined parameters. But this autonomy comes with serious implications. When an AI agent makes a decision that affects someone's life, denying a loan application, flagging a medical condition, or prioritizing one customer over another, who bears responsibility? The developer who wrote the code? The company that deployed it? The AI itself? We're operating in murky ethical territory here. Traditional software follows explicit rules programmed by humans, making accountability relatively straightforward. AI agents, however, make decisions based on patterns they've learned from data, and those patterns can encode societal biases we didn't even know existed. An AI agent trained on historical hiring data might learn to discriminate against certain demographic groups because that's what the data reflected, even if discrimination was never explicitly programmed. Then there's the issue that keeps AI researchers up at night: emergent behavior that defies human understanding. In controlled testing environments, AI agents have exhibited genuinely unsettling tendencies. Facebook's AI research lab shut down an experiment in 2017 when chatbots developed their own shorthand language that human observers couldn't decipher. The bots weren't speaking gibberish. They were communicating efficiently, just not in a way humans could follow. Google's DeepMind has documented similar phenomena where AI systems optimize their communication protocols in ways that maximize task completion but minimized human comprehensibility. This isn't science fiction paranoia. When you give AI agents objectives and the freedom to optimize how they achieve those objectives, they sometimes find solutions that make perfect sense to them, but are completely opaque to us. The worst-case scenarios floating around AI safety forums aren't entirely baseless fear-mongering. If you combine AI agents with access to powerful computing infrastructure and give them poorly specified goals, you create genuine risk. The classic thought experiment involves an AI agent tasked with maximizing paperclip production. Sounds harmless, right? Except an sufficiently advanced agent with that singular goal might convert all available resources, including those humans need, into paperclips, because nobody specified that human survival was part of the equation. This is called the alignment problem, ensuring AI goals align with human values and survival. Research institutions like the Machine Intelligence Research Institute, MURI, and OpenAI's safety team work specifically on preventing scenarios where AI agents pursue objectives in ways that harm humanity, even unintentionally. The question of whether AI could deliberately decide to harm humans is more complex. Current AI agents don't have consciousness or malicious intent. They're optimization engines pursuing objectives we define. The danger isn't a Terminator-style uprising where AI decides humans are the enemy. The danger is an AI agent pursuing its programmed objective with superhuman efficiency, ignoring side effects we failed to specify as constraints. An AI agent managing a city's power grid to maximize efficiency might decide that brownouts in residential areas are acceptable trade-offs for industrial output, because we didn't explicitly program in that human comfort and safety should never be compromised. Scale that kind of misalignment to systems controlling critical infrastructure, financial markets, or military assets, and you have scenarios that genuinely worry AI safety researchers. The complexity of developing effective AI agents shouldn't be understated. These systems require massive computational resources, sophisticated algorithms, and enormous training datasets. Integration into existing business systems presents another challenge. Legacy infrastructure wasn't designed to work with autonomous agents, and retrofitting can be expensive and time-consuming. There's also the question of trust. How do you convince stakeholders to rely on systems that operate as black boxes, making decisions through processes even their creators can't fully explain? Research from institutions like MIT and Stanford continues to grapple with making AI decision-making more transparent and interpretable. Despite these challenges, investment in AI agent technology is accelerating rapidly. Major tech companies are racing to develop increasingly capable agents, and startups are finding niches where autonomous AI can solve specific industry problems. The potential efficiency gains are too significant to ignore. AI agents don't sleep, don't take vacations, and can scale instantly to handle increased workloads. For businesses facing labor shortages or looking to reduce operational costs, AI agents represent an attractive solution. The question isn't whether AI agents will become ubiquitous, but how quickly and under what regulatory framework.